Hello guys, I'm Aman and today I'll be guiding you how to take user inputs in Unity. So let's begin. This is a beginner's tutorial. So in this tutorial we'll be seeing how to move an object in Unity according to the user's input. So this is a basic scene setup. Here we have a plane and now let's create an object which will be moving. There is a cube which will act as our player. First position it and now we will be seeing how to make this object move. But first, for distinguish between object and the plane, let's make a material and give it a pretty red color and apply this material to the cube, to our cube object, and let's rename it to the player. So now it's time to see how to take input in Unity. And but for this, let's first align our camera to the view. So we will be seeing this. Now the main part, we will first create a C# script, layer, open it up. We don't need to, it's still opening. So first remove start and update as we don't need it right now. Let's first see how to take user input. Mm, First let's make two variables. I think in this case only one will find. Okay, now uh, as we know update get called every frame. So in update we'll be updating our horizontal input. So we will be type input dot input means as we can hover over interface to the input system. This is just an interface which allow us to get input from the keyboard or from other joysticks or from any axes. So now there is this option get axis and get axis raw. So what is the difference between get axis and get axis raw? The main difference between them is in get axis its value lies between -1 to 1, and it will contain any value in between -1 and 1 and also -1 and 1. It means this is suitable for joystick. Suppose you have a joystick and you are sliding it a little bit, so it will register only a little bit amount. Like if you are sliding it towards right, it will only consider half. If you are sliding half the joystick, then it will only consider 0.5, means half the amount of the total input. But in case of raw, get axis raw, it will only consider either -1 or 1. Means if you only tilt your joystick a little bit towards right, then uh, it will clamp the value to 1. And if you tilt little bit your joystick to the left, it will clamp your value to the -1. It will not consider any value in between. It just contain the raw value. I hope you understand what's the difference. So here we will be taking input get axis raw horizontal. I spelled it wrong. Yeah. Now uh, from where this horizontal comes from. So let me show you from where this horizontal comes from. In edit project settings, input manager. Suppose your input manager will not be showing like this. So here in axis there is this horizontal, and in horizontal it is taking a negative value of left means left arrow key, positive value is right means right arrow key, or alternate negative value A and alternate negative value is D. Means if you will be pressing A or left arrow, then it will be registering as -1, and if you will be pressing D or right arrow, then it will be registering as 1 means positive value. Okay, so now let's see how is this working. Let's first debug this statement. Debug.log horizontal and apply this script to the player, and we'll be saying the values of our horizontal in the console. Okay, now as you see currently this is 0 as we are not pressing anything, and the moment I'll press right, it's showing 1 as we D is a positive button, and when we press A then it is showing -1 here. Okay, this means our script is working. Now how do we move this object left and right according to the user's input? Suppose if user presses D or right arrow, then it should move like this, and when user presses A or left arrow, then it should move in this way. Okay, so now how are we going to do this? So instead of debugging this statement, we'll be changing the position of our object. Position means here in the transform. Just wait a moment. In players game object, there is this transform. If we change objects X, then it will move left and right. Seeing it? So we'll be changing this value of X from the script. So how are we doing this? Transform dot position plus equals. This means it is actually like this. Transform dot position plus new vector 3 horizontal. We will give the horizontal value as X and 0 and 0 of the vertical and forward values. So currently what will happen, this horizontal value only lies between 1 and -1. So suppose if we want to make our object move faster, so for this just make a public variable name speed, which will be controlling our speed. So, and as we are changing position, we should also multiply with time dot delta time, which will keep our game frame rate independent. It doesn't matter whether you are playing in 60 fps laptop or 60 fps PC or 30 fps PC. This value will remain same for all of them. It will not vary as per of the frame rate. So now let's save this and go back to the inspector. And here, let's make the speed value 2. So now as we see, when we press A and D, our object is indeed moving. And if we increase this speed value, then its speed will also increase. Isn't it cool? Now suppose we also want to make our object move forward. Means we also want to move our object in forward direction. Means when we press W, it should move up, and when we press S, it should move backwards, forward and backward. Okay. So now for this, let's make another variable float. What should we name it? Forward. And in forward, so vertical. What does this vertical is? Now, what is vertical? Let's come back to the input manager in our project settings. Now vertical. For vertical, negative value is down arrow or S, and positive button is up or W. Okay, when we press W, it will register as 1, and when we press S, it will register it as -1. Okay, now this statement or this line of code is what is responsible for moving our object. Now, when we are adding this value in the x-axis, it is making object move in x direction. But now this time, in which axis we want to move our object? So this is here. We can see it from two ways. This blue axis is the z-axis, and this is the one in which we are trying to move our object this time. Am I right? Yes. So from here you can see we now want to move our object in z-axis. or in z direction, z plane, whatever. So this time what we'll be doing, we'll be multiplying vertical, sorry, forward asterisk speed time dot delta time. Okay, so now our object will move left and right as well as forward and backwards. Let's test this. Moving left, moving left and right, forward, backward. It's actually slow right now. Let's make the speed 5. And as you can see, you might be noticing one thing. Uh, when we are going backward and upward and left and right, speed is same, but when we go diagonal, speed increases. Why is this actually happening? This is because, as we know, in vector math, what happened? Uh, it is actually calculating the. Let's come here. What is happening in x-axis? We are applying this much of changing changes, and in forward direction we are applying this much of changes. But what happened when we are pressing both the keys? It is calculating the resultant vector of these two vectors, resultant vectors, and because we have some x and we have some y or z in our case, it is calculating a resultant vector in between those two, and that vector's magnitude is greater than the greater than these values, the values we are getting from here. So what we can do is, instead of directly applying this vector here, first make another vector, name it movement vector, and here copy these statements of code here. So now what we are doing is, and instead of, as we know, our speed will be same for all of them, we shouldn't be doing it like this. So this is only calculating our vector, but now we want to normalize it. There is this function normalize, which normalize the vector, means it will what it will do. Sorry, this is not normalized, this is normalized. So what this will do, suppose this has one, this is also one, but it will, when it calculates uh, the basic idea behind this is, it is converting this vector into a unit vector, means, and a unit vector is one which has a direction but no magnitude. And now we will multiply this with speed and with time dot delta time, and we will multiply that, or we will add that vector here in our transform dot position. So everything will work fine. Let's compile it and make the speed value 5. Now when we are moving diagonal, the speed remains same. So here you go. Now you can build upon it as whatever, however you want. You can see how these axes work. There is everything in here. You can also add another axis by simply increasing the number and going to the last one and changing their keys value. E, cancel, rename, interact, simply. And for jump, you can use this directly, input dot get axis jump or get axis raw jump. And for this, the positive button is space.